Q&A periods. So I want to thank Bob Dobos and Maggie Payne for being here to support our webinar. And Bob is up first. Bob, I'm going to turn the webinar over to you.
Thank you, Sean. Good afternoon or morning, as the case may be, and a very happy Friday to everybody. Another day, and I don't think I could have done it. So, I pressed the arrow key?
Yep.
All right, very good. So, this Gopher Tortoise habitat suitability rating has been going on for a little while. But, first off, I'd like to back up, and we'll just talk about the tortoise some, and then Maggie Payne will get into some serious nuts and bolts about how the thing works. Gopher tortoise natural history, it's Gopherus polyphemus. Polyphemus being the cyclop that had one eye in the middle of his head, because the skull of the tortoise has a hole in the middle of it. So they thought they were seeing a cyclops kind of animal. But that's neither here nor there, really. It's adapted to the southeastern United States. Although it's similar to other tortoises in other parts of like the desert tortoise. But this one's adapted to southeastern United States. Front feet are adapted for burrowing. You can see on there that they're not very good for walking. So, but they are good at burrowing, and they do that a lot. They range in weight from about, mass, 2 to 6 kilograms, and they might be up to 30 centimeters or a foot or so long. So they're a good size beast. The native habitat, or one of the native habitats, I think probably the maybe the index habitat, if you will, is a longleaf pine savanna. And that's a savanna is a place where they're characterized by an open canopy. They might have a lot of trees, but there's an open canopy so the sun can hit the forest floor, which allows grasses and forbs and things like that to grow on the forest floor, which, if you're familiar with deciduous forest, is not always the case. Sometimes the canopy is so tight that nothing gets through, and there's no understory. And that wouldn't work for the gopher tortoise. So they can eat grasses, legumes, mushrooms, but their range is kind of interesting. It's limited by the physiology because the sex of the turtle, the eggs are laid, I guess you would call it neuter, genderless. And the temperature during the incubation period determines the sex of the eggs. And if it's above 30 degrees, then the hatchling tortoises will be females, and above or below 30 degrees Celsius, they produce males. And so that just seems kind of an odd thing, although not entirely unusual, I think, for reptiles. But it would make for some interesting logistics of making sure a population has a mix of sexes so that it can continue reproducing. Generally, the soils that they grow in or they use are very sandy, coastal plain soils like the sand hills in Georgia and North and South Carolinas, but really only the Georgia part because that's the only place where the temperature works. And there's a lot of sand in the southeast because generally about the last thing everything saw as the sea level went down or the Earth's surface went up, everything ended up being beach and dunes. So there's plenty of sand in the southeast. And so the eggs incubate for 80 to 100 days. And just thinking trying to keep 30 Celsius is pretty warm. And trying to keep those temperatures up, I've never found out if it's an average temperature or what proportion of the incubation period needs to be above or below 30 degrees. I haven't found that out yet. Maybe if there's a turtle physiologist in the room, they can elucidate that one, but put a comment up. So, perhaps though, we don't really think in terms of slope aspect in the coastal plain, but perhaps the tortoises can use the slope aspect either knowingly or unknowingly to have a mixture of sexes in the eggs in the progeny. And more on the natural history and description of the beast, the gopher tortoise is an obligate burrower. So he's a good soil scientist kind of animal. He has to dig. He's just like us. He's got to dig. And the burrows provide shelter for the tortoise from predators and protect him or her from extremes of heat and cold. And the tortoise is an industrious sort, and he might have or she might have maybe 4 burrows or so in about 4 acres or 2 hectare domain. But what's really neat about them is that not only do they use the burrows, but lots and lots of other animals use the burrows. And depending on who you read, it could be anywhere from 360 to 420 other species, which means that the gopher tortoise has an inordinately high impact on the ecosystem compared to how many of them there are. They have a lot of impact. They provide a lot of, I guess, ecosystem services, you would call it, for their compatriot vertebrates and invertebrates and anything else wandering the landscape. So they're what's called a keystone species. They're a very important part of the ecosystem. More on the natural history. The temperature relationships limit the range of the tortoise. So even though the sandhills in Georgia, up there in northern Georgia, those sandhills will extend up to South Carolina and to North Carolina, as far as I know, they don't get into the northern end of that because the temperature relationships aren't right. And there are threatened in the western range, part of the range, and the remainder of the range they're protected or something like that. One of the interesting things about them, though, is the pine savanna is fire dependent. And it's theorized, and I read this morning, that the Native Americans used fire extensively in their management of the North American continent. And so they did it for game management and for defensive visibility, because the understory you can't see through. If you've ever mapped in a deciduous area in the summertime, you're limited to about 10 feet of being able to see. But burning out this, going through the pines like that, you could probably see a quarter of a mile or so. Half or a quarter of a mile, but a tenth of a mile anyways, depending on the density of the stand. So they did that, and I suppose for fun too, because burning off the large areas is kind of a hoot sometimes. And I would be surprised if the tortoise wasn't on the Native American menu. And so they were managing for it just like they managed for buffaloes and American chestnuts. More Gopher Tortoise natural history. They're challenging for survival now since in the post-Columbian North America. A challenge for survival, predation from people. They were also known as the Hoover chicken because they're, I have to say it, Kathy, they're a large, slow-moving, good-tasting animal in an area of extreme poverty. So go figure, they're endangered. Well, they get run over by cars, so we put up gopher tortoise crossings. Foxes, skunks, and armadillos eat them. They eat the babies, eat the eggs. Habitat loss is the big thing right now. And not just development, but the fire ecology is lost in some places because we don't burn, because you have the never-ending battle of Smokey Bear saying, prevent fires. Then you have this poor little tortoise saying, I'm starving because there's no grass in my understory, please light a fire. And so there's a dichotomy of uses there. You have the species management on a long term versus perhaps a short-term aesthetics, because a burnt-out place just looks ugly for a couple, 3 years. And so, in order to start some conservation efforts, or to support conservation efforts, and that's, there are a lot of agencies, federal government and state government agencies involved in protecting and enhancing the ecology for gopher tortoises. And it starts out, since they're an obligate burrower, you've got to have soils that are suitable for them to burrow in. And so they got together, I'm thinking it's around 2010, according to some documents I have, and they developed a criteria table, just like we do in the Science of Interpretations class. And then they talked to me about making it into an interpretation in NASA so it could be mapped and distributed. And so that started in about 2013. And this is 2017 now, and so we get an idea that this has been quite a project to work on. A lot of back and forth and tweaking. Things just, the initial model in 2013 looked pretty good out in the western part of the range, but didn't really fit very well in Florida. So we figured there's some sort of an effect of the high temperature and the rainfall. Even though the rainfall is quite high, it's just so hot that the evapotranspiration is quite high. And so modeling that effect has been a challenge. And even just simple things like modeling the sandiness is, not a trivial task, because sandiness where? The upper 10 centimeters, 20 centimeters, meter, what makes a difference to the tortoise? And so it gets to be a non-trivial task trying to say that this soil is better for a tortoise to dig in than this soil over here. But those are the kinds of things we were trying to get a handle on, trying to quantify. And it's important that we be careful and thorough and honest as possible in creating this, because there's going to be a considerable, and there already has been a considerable amount of money and effort tied up into conservation efforts. And so we want this to be equitable and fair and scientifically correct. And that being said, I'll turn it over to Maggie, who will get into this a lot more deeply. There you go, Maggie, take it away.
All right, thanks, Bob. Can you hear me?
Yes.
All right. Yeah, so I just had Bob do a little intro on what the Gopher Tortoise is all about and the history of this interpretation, because he was the one that had been working on it for a while. I came on in just this fall in 2016 as I was detailed to the National Soil Science Division on the interpretation staff. And one of my tasks was to work with the folks that had been working on this Gopher Tortoise interpretation to try to finish it up and address the issues that Bob had alluded to, with mostly in Florida and in the Georgia area, where this interpretation wasn't quite working as well as they had wanted it to. So what I'm going to do is I was basically given these interpretations that were written into NRCS and the criteria table and all the background that had gone along with it, and we were trying to finish this thing up. So if you're interested in hearing more about the history, there is another archived webinar that I think was done in 2015 that covers some of this stuff as well, but we're trying to bring you up to date on that. So what I'm going to do is go through just some of the changes that I worked on with the group in some detail on the things that were causing us issues, and hopefully have come to some conclusion on them. I'll start off with just a brief anatomy of an interpretation, I call it, just to bring everybody up to speed on how these things are put together so it makes some sense to you. So with any interpretation, we start off with this criteria table like Bob had mentioned. For this one, we have the criteria over here on the left-hand side. See if I can do my pointer. Here it is, over here on the left-hand side of the criteria. And so for this one, this is just, we also call them the sub-rules. We had 7 different criteria, and these are the things that are going to impact what the interpretation is all about. So where gopher tortoises are going to be making these burrows. I like to put on my criteria table what the soil property used is, because this is basically out of NRCS what we're looking at in particular in NRCS that'll define what that criteria is. And then over on this side you put together your groups, so if it's unsuited over to well-suited, and each one of those criteria are basically given this fuzzy number rating. So it's rated from 0 to 1, 0 being totally unsuitable for this use or for gopher Gopher Tortoise habitat, 1 being very well suited or well suited for habitat. And then in the middle would be a number between 0 and 1. This was put together as a suitability rating. So what happens is each one of these criteria is given this value between 0 and 1. And then because it's a suitability, the lowest rated criteria is going to equal the overall rating for the soil component. So that just means that, say, we have everything is well suited for a Gopher tortoise except for in a certain soil there's ponding that occurs, and that would make it unsuited because that's the lowest value that you would have, and so that would make that soil in particular unsuited, even though everything else is meeting the suitability criteria. And so that's kind of how an overall view of how these things work, if you're unfamiliar with it. So for this one in particular, we had these 7 different criteria. These 5 that I have the information filled in here are the ones that I think from the beginning were sort of in the literature that they didn't cause a lot of issues. They were pretty straightforward. So depth to the restrictive layer. So these tortoises are burrowing. They like to burrow at least 2 feet, I think is the minimum, or around 50 centimeters. And then they'll go all the way down to 200 centimeters with their burrows. So we're looking at depths that go pretty far down into the ground. So a restrictive layer that's less than 50 centimeters is going to be unsuitable for them. Greater than 100 or 200 is going to be suitable. And then things like the amount of coarse fragments, if there's ponding or flooding, are other criteria. And then if it's too steeply sloping is also a criteria that we looked at. So those are sort of the straightforward ones. I just wanted to show them, but I'm not going to really discuss them very much. The ones that I'm going to focus on here are the 2 that sort of were causing some of the issues with the interpretation to start with, and the ones that we spent a lot of time tweaking and going back and forth on. So the first one is what was called at some points the Diggability Index. It ended up being really just the soil texture. And so, like Bob had mentioned, these tortoises like to dig in sandy. They prefer the sandy soils. And in the literature, they had said over 70% sand is really what they prefer. Less than 15% sand would be not sandy enough for them. And then the other one is the depth of the seasonal high water table. So that was one that we had a lot of back and forth on, and Bob talked a little bit about how the temperature makes a difference, and so I'll get into the details of that today down the line here. But this is how our criteria table was kind of set up. It sort of summarizes the whole thing so you can see it all together. The first thing I just wanted to cover was the soil texture criteria that we talked about. So this is what it looks like in NRCS. We started off with talking about what this picture is showing is just one of the sub-rule in NRCS. So this was the first, or one of the versions that was in there. Basically, this is just trying to tell us the ease of excavation, reflecting the tortoise's preference for sandy soils. It may seem straightforward, but then once you start looking at it, you're looking at both how much sand is in these soils, and then where that sand is. Is it on the surface? Is it all the way down to 2 meters? Is it just the top 50 centimeters? And so that all of those things are going to make a difference. So this attempt was just basically, let's see here, my little circles, to take a look at the data. It looks at how much sand, those little blue ovals are saying, the percent sand in these different layers. So the top one is 0 to 30 centimeters, then it is every 30 centimeters, 30 to 60, 60 to 90, and so on. And it's looking at percent sand and percent clay, and then putting those 2 together, and then weighting them by depth. So that's what these multiplying by numbers are. So it's more highly weighted at the surface, and then it decreases in how much weight you're giving these ratings as you go down. And so this is based on the data. It's sort of a natural and realistic assessment of what, saying it's better that we have sandy textures at the surface. It's better if they're sandy all the way through. And so it did give some accurate ratings. The problem with this one was that it wasn't always matching up with the arenic and the gross arenic soil subgroups. And so we wanted to show that all the gross arenic soils were the most suitable soils and give them the rating of 1. And they weren't always, it wasn't always doing that with this attempt, partly because we had different breaks. We had these 30 centimeter breaks versus 50 and 100 centimeters, which are the taxonomic breaks. And so, somebody's saying, can you explain gross arenic? Gross arenic is the taxonomy, soil taxonomy, and it basically just means over 100 centimeters of sandy textured soil. So it's from the surface down to at least 100 centimeters, it's sandy textures. And so we wanted, so certain soil series are gross arenic, and we wanted those to be showing up all the same ratings. So what I did is I kind of simplified that a little bit. So I looked at just the weighted average of the sand from 0 to 50, and then from 50 to 100, giving more weight to the surface to that 0 to 50 depth. That's the multiply by 0.7 is. And so what that was attempting to do was look at just how sandy the soils are between 0 and 100 centimeters and give a number based on that. So my little diagrams over here are kind of showing some different possibilities for profiles. These first two, well, first let me talk about this one. This one over here, so it would say, it would give a pretty high rating because it's sandy all the way down to 50 centimeters. A finer layer comes in below 50, and so it's going to lower the rating a little bit, but not significantly. These other two, the issue with looking at it this way is that from 0 to 50, one of them is sandy on the surface, and then you run into a clay layer. One of them is clay on the surface, and then it's sandy. They're going to end up with the same value for a weighted average of sand from 0 to 50, potentially. But if you were a tortoise, you would probably prefer this one over here because you would dig down to whatever depth I have here, 40 centimeters, and before you hit the clay. This one, it would be finer on the surface, and you might not even want to dig there. So you would want this one to have a lower rating. And so in order to kind of take a look at that, we added another little caveat to this soil texture rating that just basically looked at the depth to a layer with a clay content of greater than 20 centimeters. So in a lot of these soils, the weighted average wasn't really capturing it because you have sandy textures and then you have a layer that has a higher percentage of clay. This layer might be thick, it might be thin, but ultimately the thickness doesn't matter that much to these if you're a tortoise digging a burrow, because you're going to hit something that you don't want to dig through anymore, and you don't know how thick it is. So reaching a layer with a clay content greater than 20% at a shallower depth is going to sort of lower your rating for the soil more so than if you reach a clay layer at a little bit deeper depth. And so that's sort of what we ended up doing with our soil texture sub-rule for this one. I wrote out down here what that clay sub-rule is doing, where it gives a value of a rating of 0 if the clay layer is at the surface. It gives a value of 1 if the clay layer is greater than, if there isn't a clay layer, or if it's greater than 100 centimeters. And so that's what that one did. That's just circling it. And then just briefly, I wanted to mention that we also did switch around a little bit this depth to restrictive layer sub-rule. So one of the sub-rules that I showed at the very beginning was how deep the soil is to a restrictive layer. So restrictive layers in our database are usually just limited to these, like a plinthic zone, a fragipan, ortstein, things that are entered into our databases as restrictive layers. We also just wanted to incorporate into that the depth to a higher clay content, so a content of 35% in the literature about the tortoises was determined to be sort of the limiting layer for them. And so we incorporated that also into this depth to restrictive layer subrule. And then finally, I just want to talk about the depth to high water table. So where the water table is in the soil is really important in these tortoise habitat areas. In some of the information that I was reading, it says it's one of the most important characteristics in burrow site selection is where that water table is. Like I said, typically the burrow chambers are at least 2 feet below the soil surface. They can go all the way down throughout the profile that we're describing for soils. But they also like to be close to the groundwater table, especially I think in these warmer, the warmer part of their range. They use the groundwater table for thermoregulation, so it actually helps them cool off. And like Bob had mentioned, the temperature is important in producing eggs and things like that. And so temperature regulation and being close to that water table is an important thing. In the initial interpretation that was written, the Gopher Tortoise soil interpretation, this reading, looking at where the seasonal high water table was fairly straightforward. We just said if it was less than 50 centimeters to the water table, then that was unsuitable. Basically, if the water table comes up into the area that they're burrowing, they're not going to want to be there. And so less than 50 centimeters was unsuitable. Greater than 100 centimeters was fine. Anywhere in the middle was kind of in the middle. And this worked for a lot of the range, but this was the issue in a lot of the areas in Florida. And this map here is showing one of the good things about this data, this interpretation is we have this huge data set of ground truth locations of where Gopher tortoise burrows are. So in Florida, they took this soil interpretation and they took where the burrows actually were, and they put it together, and it wasn't lining up. The blue colors on this map are what was ranking as unsuitable soils for Gopher tortoises in the original interpretation. And you can see that a lot of those burrows are actually on the unsuitable soils. And so this is what prompted us to relook at this part of the interpretation. Using all this point data in Florida, they took a look at where what the drainage class of all of these different locations were. On this map, the green dots are Gopher tortoise burrows on poorly drained soils. And so you can see there's quite a few of those. This graph over on the left-hand side, this bar graph, is showing statewide what the drainage class of the soils were where they found the burrows. The red is the excessively drained soils. The blue is the poorly drained soils. So you can see that even though we're expecting, or the interpretation is telling us, we shouldn't find Gopher tortoises on poorly drained soils, in Florida, almost half of the burrows were on these poorly drained soils. When they split this up between, this red line is showing a line between the thermic temperature regime and the hyperthermic temperature regime in Florida, and when they divided their points up based on that, they found that this graph on the top on the left-hand side is showing in the thermic area where all those burrows were found. Most of them were found in the excessively drained soils. The lower graph is showing in the hyperthermic area, most of the burrows were found in the poorly drained soils. And so there was obviously something going on with the temperature with where these burrows were found, if they're found in poorly drained soils or not. And so we needed to figure out how to incorporate that into the interpretation to make these poorly drained soils in southern Florida rank as something more than unsuited. These are obviously at least somewhat suited for gopher tortoises because they're all there. So some of the ways, we kind of looked through some of the ways that we could address this, and because it was based, like Bob had said, probably based on the temperature and precipitation influences would be influencing where that water table is. They did some mapping on using some of the soil data. This is within NRCS, using the data on climate. And so looking at areas where there's probably more evapotranspiration than precipitation. And that's what this map is showing. It's the mean annual precipitation minus the potential evapotranspiration from data that's held within our NRCS database. And so it's showing basically a water deficit, where the red and orange areas are higher evapotranspiration than precipitation. The blue areas are more precipitation than evapotranspiration. And you can see that it kind of is showing a trend here, but one of the issues with this is that it's still, we kind of have boundary issues. So we don't want to really introduce into our interpretation issues with boundary mismatch over the states and the counties. So one of the other data sources that we had was the PRISM climatic data. And so they looked at potentially using this. This is climatic data, the same information, so water deficit throughout the whole country. And this is it. Excuse me. This is it zoomed in to our area of interest. And you can see that it's at least a little bit smoother, and that southern part of Florida is showing a much higher water deficit. So that's a potential way to use, a potential data source to use for our interpretation. It's also showing, though, that up in Georgia there's a high water deficit as well. And when we ran the interpretation using this data, incorporated into our water table data, it caused some problems, especially in that area in Georgia. And then in some of the soils in Florida, we're still ranking out not quite where we were wanting them to. That wasn't matching up with the field data that we had. A final analysis that they did in Florida was looking at where the gopher tortoise burrows were based on the MLRA, or these major land resource areas. And I know you can't read the text on these graphs, but the little pie charts are showing the drainage class of where the burrows were found. The blue is the poorly drained soils. The red is the excessively drained soils. And you can see that those southern MLRA regions, the majority of the burrows were found in poorly drained soils. The northern ones, the majority were found in excessively drained soils. And so we decided that using MLRA might be a good way to sort of divide up these areas and adjust the water table a little bit so that we can adjust our interpretation for those southern areas. So this is the MLRA map that we used. So the red MLRAs, that southern part of Florida, we're basically adjusting our water table assessment in those areas. From our initial water table assessment was from 0 to 50 centimeters, like I said, would be unsuited. In these southern areas, we were going to adjust it so that it would be adjusted by 30 centimeters. So 20 centimeters and less would be unsuited. Anything else would be all right. And then a minor adjustment for the sort of salmon-colored MLRAs, and then just leave it as is for the rest of the area, because the interpretation was working all right for that area. This is the map that was produced from that interpretation. The dark green is highly suited, light green is moderately, and then yellow is less suited. White areas are unsuited. You can see that in southern Florida we got a lot more moderately suited soils, and so that was a step in the right direction. It worked well for that area. We had some issues in that area that's circled in red, where with some boundary. You can still see those boundaries between the states maybe something going on there. So from there, it was decided that one of the issues that was still causing problems was that the very sandy soils in southern Florida would have a much more dynamic water table. So they might have a shallow water table, a very shallow water table at some points, but it would very quickly drop back down, and would probably be more suited to tortoises than some of the finer textured soils in those areas. And also just the activity of the tortoises. They're active year-round in these southern areas, and so they're able to, if the water table is coming up very shallow, they're able to just leave their burrows or go to another one. Whereas in the northern part of their range, they are inactive for part of the year when it gets too cold. So if the water table is coming up into their burrows, they might have less of a chance to get out of there. So for this reason, we also wanted to add something in there with the texture of the soil and how that's going to influence where the water tables are. So from that map that I showed in that last slide, and we changed a little bit which MLRAs were being looked at, so that we took out, because of those issues in Georgia and Florida right here, we took out that MLRA 153A, I think, so that there wasn't any adjustment there. So what that did was, for these MLRAs, we kept with that standard, unsuitable, less than 50 centimeters. This blue is supposed to be the water table down here. So anything higher than this would be unsuited. Anything lower than this would be well suited. And in the middle would be in the middle. For those very southern MLRAs, if there was no layer with greater than 20% clay within 100 centimeters, we were saying that a water table up to as shallow as 20 centimeters would be all right. Any shallower than 20 centimeters would be too wet, and greater than 70 would be well suited. And then if there was this clay layer that came in, or a layer with higher than 20% clay that came in at less than 100 centimeters, then our water tables could be as shallow as 30 centimeters and go as deep as 80 centimeters. So what this chart is just showing is, and then these MLRAs in the middle here, these sort of orangey colored ones, are kind of intermediate. So we had the water table adjustments the same way, but just not as significant. And so that's the way that we ended up dealing with the water tables, trying to adjust for using these MLRAs as cutoffs between areas that would be the hyperthermic areas where the water tables would be fluctuating a lot more, and those where we would just stick with the less than 50 centimeters as a water table. And this is the map that resulted from that last one. You can see that in this red circle, you can see that those areas changed a little bit based on that last version of the interpretation. And finally, they did do, this is out of Florida. Taking those points is such a valuable data source to have. So they took the points where they found all the burrows and laid this over our soil interpretation. And you can see that they line up pretty well with where the well-suited soils are where we find most of the burrows. So well-suited and suited have almost all of the burrows in these locations that they analyzed. So the final stages of this interpretation, we're still in the determining what these ranges are. So this is just showing two maps of changing. We haven't changed any of the values here. These are the fuzzy number values that get spit out of the interpretation from 0 to 1. Just deciding where you want to make those breaks between unsuitable and suitable can change what your map looks like. You can see how there's a lot more of the yellow on that lower map that's considered less suited. So just working with the users and deciding what we want the wording to be and what it's going to be used for can make a big difference on how you want to group those values. And so that's still kind of being worked out. And then just getting approval from all the parties involved and publishing it either to Web Soil Survey or just by the state, depending on how people want to manage that. And so that's where it is right now. Lessons learned and implications from this interpretation, and I'll let Bob chime in if he wants to here. But in my opinion, I think that this kind of shows how regional interpretations can work. I think there was some discussion at a few points through doing this process that maybe we need separate interpretations for separate areas because we were having those issues where it wasn't working at all in southern Florida and it was working fine in other areas. But I think there's definitely value in being able to bring all the information into one interpretation so that we're not kind of working in parallel, doing multiple things for different areas. We still do have issues with county and state boundaries. We ran into that with some of the water tables were populated slightly differently in the Georgia counties than the Florida counties that were right over the border for the same types of soils, and that's kind of where, like that area that I was highlighting on the map, where some of those issues were coming up with that water table part of the interpretation. Also, I mean, there's many ways to reach similar answers, especially where this interpretation went from Bob working on it to me working on it to other people's input. You can come up with different ways of analyzing this data that all reaches a similar conclusion, but in different ways. In this one, we were really lucky to have all that field data so that you can really tell if you're doing the right thing, if it's working out. And then when in doubt, go back to the research and make sure that that kind of feeds into my last point of being able to defend and explain the results to users. I think one of the complaints on using that PRISM data was that it felt like kind of putting it into a black box and then having some number get spit out. And that's the way a lot of our interpretations can kind of feel. But being able to explain how we reach these results to the people that are using it, I think, is a really important part of this, because to avoid the misuse of our interpretations, because we don't want people to take them and use them for something that they weren't developed for, which can happen often. So that's all I've got. I just want to just thank the folks in the region that helped me out with this. And as I was finding pictures, I found that it was April 10th is Florida Gopher Tortoise Day. So we're almost there. We should celebrate on Monday. And that's all I've got if anybody has any questions.
All right, thanks, Maggie. And I'll remind people to enter a question. It's best to put it in the Q&A pod, and we'll look for those questions. Are there any questions from here in the room with me?
Yeah. Did you mention anything about just how, we talk about non-trivial tasks and just the rating class names for this particular interpretation were a non-trivial task, weren't they, Maggie?
Yeah, you mean saying unsuitable, those names? Yeah, I mean, we went back and forth, and I don't know that we're even settled on the names that I put in this presentation, but yeah, I mean, because this is used for regulatory and because it's used by people that, as with any of our interpretations, that aren't soil scientists, you want to not totally exclude some things by saying, well, these are unsuitable, when maybe there'd be areas that would be all right. So yeah, deciding on those names and deciding on those breaks can be a really important part of it.
Good job, Maggie.
Thanks.
Yeah, a lot of comments. Great presentation. There is one question in the chat here. Wouldn't you want greater weight further down in the profile, since gopher tortoises like to burrow to 200 centimeters?
Yeah, well, we gave greater weight to the surface because the idea was some of the burrows, from what I've been told, I've never personally even seen a gopher tortoise, but they like to, some of them will burrow only 2 feet or 50 centimeters, and that's as far down as they'll go. But if they can get deeper, that's better. They're better protected. But if there's anybody online that is a gopher tortoise expert, feel free to chime in on that one.
All right, some questions are coming in. So were there any discussions about ratings with regard to mapping a concept and design, for example, soil associations?
Not in my experience. I don't know if, Bob, you have had any discussions on that.
I'm trying to remember, Maggie, because it was a little bit ago that when we talked about that. I know that there's parts of one of the states where the mapping was a lot broader than normal for, most of the rest of the areas. And so mapping at design became somewhat of an issue there. But I can't remember the particulars offhand because that was a while back.
Yeah, I mean, I guess I would just say that the interpretations are really done off of components, so the components that are getting those ratings. And so it might be just sort of post giving those ratings on how you would deal with that, if that makes any sense.
So Maggie, if there was a group that didn't like the assessment, wanted to improve it some more, what would they need to do to improve the assessment?
To improve
what
you mean this
what
one
we have
in particular?
now? Yeah.
It would be, I mean, they could come to us, and if there's more issues with it, to identify which areas are having problems.
And which soil properties are causing the problems too, because the way these things are constructed, we can report the fuzzy numbers for each sub-rule. And you can see, well, this soil, this Albany soil, that's fine, it's good, the textures are suitable, the water table is maybe not suitable, but everything else looks about okay. And so you can focus in on a particular soil property to see how it's, if it's the thing that's impacting the overall rating unfavorably, or more favorably than it should be. It can go both ways. You can have soils that they would say, well, I don't think this soil this should be suitable, but that's generally not the way it goes. And like normally or typically, interpretive models are, I don't like to say they're ever finished. They get to a point where they can be published. We feel fairly confident, but there's a lot of black swans out there. Maybe not a lot of them, but enough of them just to keep the game interesting. And so something will crop up that we hadn't thought of before, or some magic storm or perfect storm of soil properties will come together and make things rate out differently than what we observe the actual activity on the landscape to be. So it's an interesting thing, and it's always dynamic. If you ever have questions about interpretations, get a hold of somebody and say, what the heck's going on here? Why is this like this? And sometimes it's just a plain old data error. Sometimes it's a model error. And sometimes it's just something we plain old overlooked because we didn't know to look for it.
Yeah, and I see the question on southeastern Georgia. I mean, that one region, I think, was a problem, that southeastern Georgia and northern Florida. And I mean, we did work with with the soil scientists down in that region and tried to tweak it as well as we could. But again, sometimes those boundary issues and how things were mapped and how the data was entered for different soil survey regions sometimes was causing issues where it would, in one region it would be ranking out all right, and in other regions it would make the rating too low. And so we did look at point data in Georgia too. I didn't have any maps with those on it, but that's been looked at as well.
All right. Well, thank you, Maggie. Thank you, Bob, for your time and effort to make this presentation today. And thanks to all the participants for joining in. We had more than 50 people join today's webinar, and the on-demand recording will be available on our National Soil Survey Center YouTube channel within a few business days. So feel free to let your colleagues know about this training opportunity. And this concludes our webinar presentation.